Okay, let's on to our next little module here. Second module, second video for week 3. And the new thing here is the collection objects. F strings. F strings are kind of a minor thing, but the big new thing is the collection objects. A collection object is when you have a group of data that needs to work together. So, for example, all our variables so far have been one thing, like x equals 3, but x doesn't equal 3 and 4 and 5. It's just one thing, and it equals, right? Name equals Bob or something like that, but not Bob and Jack and Sam and whatever, right? So, say you're reading data out of a database and you're reading a customer record. Well, you would have their first name, last name, phone number, and address maybe. So you'd have a bunch of information about that customer. Um, Also, you might be dealing with a bunch of customers. So instead of having first name, if we just use regular variables, you'd have to have you might have customer first name 1 or customer first name 2 and customer first name 3 2. And so want if you want to use 3 customers information all at the same time. But so we want a more general way to scale that up where we could work with data with any number of customers, or for orders or any number of orders, or if we're doing business analytics, any number of observations, lots of rows or columns of data and things like that. And that's what the collection objects are. They're a collection of the base variables that we've already learned. So you'll have a collection of integers or real or floating point or strings and things like that. So we're building upon the regular variables um, and to build more complex ones. The string, it can sometimes be thought of as a collection of characters, right? And you saw how we did indexing and slicing of strings. These other collection objects will have types of indexing and slicing. Some of it's the same as we did with strings, and some of it's similar but a little bit different. So we'll see that. F string. So this is a kind of a smaller topic here. F string, kind of a little supplemental topic. It is F stands for formatted, so it's for making formatted strings. And there's really a lot you can do with formatted strings. And I'll just cover a little bit of it. It's a really good thing for printing so many dollar signs or printing columns of information where the columns all line up and stuff like that, right? If you had a print in an F string instead of a regular string in a while loop, then it might be going through like different pieces of data and print that all out. So here's the basic concept, but there's way more you can do with it. So an F string is something you'll recognize with an F prior to the first quote, right? So you guys know what a string is, something in quotes, single or double. An F string is just when an F, the letter F, small letter F, precedes the first quote, and then that means this is an F string. You can use it, the F string can be directly used in your print statement, like line 15, or it can be done in a string assignment to a variable, like in line 7. So let's look at what's going on. If the F is put here, we have a string in quotes, and the regular characters are still just characters in the string like they used to be. The new thing is squiggly brackets indicate where a variable should be substituted, right? So we're saying the price is $59, right? So the squiggly bracket says insert the variable price here. The :2f means insert it as a 2-decimal floating point number. And then the closing squiggly bracket. So basically, the F is saying this is a string that might include the squiggly brackets, right? The squiggly brackets are the new thing. And if you just put if we use squiggly brackets in a standard string, it would print out just squiggly brackets. They'd just be a character. It doesn't mean anything to a regular string. But if it's an F string, it says anytime you see the squiggly brackets, that means some type of variable substitution. It could be math. Instead of just a single variable price, we could have price times 10. So you could put some math in here. And it just gives you, now we could have done this with a regular string and used in the print, we can use commas. The commas don't work between strings and text. We could use concatenation, the plus sign, right? So if we did this without an F string, we could piece these pieces together, but then we'd have to convert price to string on our own. So this is doing that for us. So it makes formatting easier than doing conversions and commas and stuff on your own. And again, great for columns. We'll see later. So when I print text, it prints the price is $59. Um, the F string, line 15, shows an F string just inside the print. And usually we won't have, like if we use an F string inside our print, we're not going to have multiple pieces separated by commas inside the print. Because any variables we want, we can substitute in there. Okay, so that's the F string. Try that. And so, right, there's a whole bunch of where I have this 0.2F, right? That's kind of cryptic. You'll have to, there's big lists of things that can be done there. All right. So F strings for formatting your string, an improvement over the basic strings, better way to substitute variables, usually. Collection objects. So there's going to be 3 collection objects. If we go back up to my listing, tuples, lists, and dictionaries are 3 different collection objects. And my 4th example will be a list of dictionaries. So these are collections, right? So if you have like a list of integers or something, right? It's a list of something, right? So it could be a list of lists. These things all can be nested inside each other to any level of complexity. And we're going to see later in the course, they often are nested to complex levels, kind of when you're sending data across the internet to like a server or something, because you might request information about something from a server, and there's a whole bunch of components to that information. And in that case, they're going to be embedded in one of these complex objects so that you're getting one variable back from the server, but it has lots of stuff in it. So you can have a basic tuple list or dictionary, or we can embed them in each other. And we're going to see in this a list of dictionaries. So let's scroll down to that. Collection objects, and we'll start with tuples. So tuples are immutable. Immutable just means we cannot change individual components of it once we set. So if we say my integers are equal to, so this is let's first look at what a tuple is. So this is a tuple. The name of it is a variable name. Variable names are the same as we've learned. I called it my integers. It equals. A tuple is indicated by parentheses. Parentheses with things separated by commas means it's a tuple. That's kind of the definition. So line 12 is the definition of assigning a tuple a variable name. So the tuple my integers has that in it. Y equals 2 is y equals 2 is actually not a tuple. Y equals 2 is the integer 2 in mathematical parentheses. Line 15 is shown if you have a tuple and the tuple only has one thing, it must still have a comma, because look at the difference between 13 and 15. 13 means those are like mathematical parentheses, so it's a 2 in parentheses, so the result is 2, and that's the integer 2. Line 15 says the integer 2 in a tuple, so it's a 1-element tuple. Kind of a minor aside there. Okay, so my integers. What can I do with my tuple? I can index and slice, right? So line 18, print my integers, 0 indexing. That means the 2. Print from 1 to 2, not including 2. That means so 1, 5 to 2, not including 2, will print the 5. 1 to 3, starting at 5, going to 3, not including the end, will print the 5 and the 99. So slicing and indexing of the tuple is very similar to the slicing and indexing of strings we saw. Okay, and here's the output. All right. And and it's just so I can have some collection of whatever. These can be any data type. Now, the immutable thing just means that this index cannot be on the left side of the equation. I'll write, I'll put this in a comment because it can't be executed. You can't say so see this, if I say my integers, so that means the my integers variable is the same variable I've already been using, but I want one of those numbers changed, and that you cannot do with a tuple, and that's the what immutable means. This line of code in line 21 could be done with lists. So let's move on to lists. Lists are mutable. um, let's move down here. Just a little aside here. We have the length function. How long is your tuple? Well, you might not know, right? So here's another tuple. Uh, check out the data type. The data type of the different elements of the tuple can vary. Same with list. So we have different data types. Um, and then we ask how long our tuple is, and that prints out there. Oh, there it is, 4. So the length function works with any of these. It works with a string, and it actually works with any of these compound variables. Another example of the immutable I had mentioned, x equals 2, 3, x equals 4, 6, right? So this is perfectly fine. This is saying I'm taking the x variable and putting something brand new in it. That's kind of what we've been doing before, right? We said x equals 2, then later we said x equals 4. It just replaces everything. The thing you can't do is replace part of it. If x is a tuple, you can't index into the x and assign just that. Okay, so that's, you can reassign a variable just like any variable, but you cannot go inside an existing tuple variable and try to change information. That actually it's important, kind of like when we're doing high performance computing, because computers can work faster if they know this stuff can't be moved around, like it's set in memory once. So that's kind of one of the values of the tuple, is things execute faster. So if you think of like training an AI system, you might use tuples. All right, so lists. Let's move on to list. First of all, let's define it. Item 5, line 5, x equals square brackets. Square brackets, things separated by commas, you have a list, right? Almost like a tuple, but we have the square brackets instead. Um, Indexing and slicing of the list, it works the same way as indexing and slicing of tuples. Nothing new there, no problem. Print x3, and it printed out the 34. Remember, it's zero-based indexing, so 0, 1, 2, 3. Print x3 is 34. Here's the new feature of a list that wasn't in the tuple. Line 7, x3 equals dog, right? And then we print out x3 and prints out dog, and print out x. You'll see there's now a dog has replaced the 34. Okay. And basically, this is implemented in computer memory different than the tuples. It's implemented in a way where you can move stuff around, right? Because the trick is the word dog takes up a different amount of space in memory as the number 34. So executing line 7 has Python moving stuff around in memory. So it's called mutable, means it's easier to use, more flexible. You can do what you want. The computer runs a little bit slower. Normally, I don't care about that, but if we're doing something a million times, like AI training and sometimes inferencing, we might care. So a lot of stuff we're gonna use a list. In this class, we'll mostly use lists. We're doing stuff that performance is not a problem in that range. Here's some list methods that you can use, and these ones don't work on tuples, partly because of that immutable quality. So we can append to a list, right? X dot append 35. So To understand this, realize we're doing a method instead of a function. So that means the append method is being called on the variable x. And sometimes the method simply changes that variable without the need for an assignment in the equal sign, right? So here we said the variable x is equal to a list. Square brackets tell it's a list, commas separate the items in the list. That's x. Append 35 means add to the end of that list of 35. And you'll see when we print out the X here, down here it has the 35 on it. And you might think you have to type X equals X dot append, but it's the append method is already being called on the variable. So it makes a change to the variable X and an assignment isn't needed, but the variable X has indeed changed in line 4. So um, the dot is the method syntax, and a method can change the variable without assignment. In other situations, you might. Print x, my tuple. Um, and let's see. The sort function sorts a list. Um, let's see. Reverse function reverses the list in place. So you can see why things like reverse and sort cannot work on a tuple because the tuple is immutable and couldn't be changed. All right, so our third item is the dictionary. A dictionary is when, so in the tuple in the list, each item in the tuple list was just indexed in a particular order. We had to keep track of the item by what order we put them in the list. Like the first integer in our list might have some meaning. I don't know, right? Well, sometimes we want to address those items in the list by a name, and then don't have to remember the order they're in. If we just say we want to use just one, maybe that the fifth number in your list is the phone number, right? So we might want to just call it phone number and not have to remember it's the fifth item, something like that. And that's what's going on with the dictionary. The items in the group are identified by a name. So customer one, here's a change in syntax. Squiggly brackets means dictionary, right? So we had parentheses were tuple, square brackets are list, squiggly brackets are dictionary. So customer one is a variable. I set that equal to a dictionary. The items in the dictionary are separated by commas like they were before. So this dictionary has two things in it, but they're named. So the first thing is the first name, and the person's first name is Ada, and the person's last name is Lovelace. Um, and now I can access that information by the first name instead of using indexing, because knowing that index 0 is equal to the first name is not very clear, hard to remember. And also, it limits you if you want to change this, right? Maybe I have a third piece of information. Maybe it's a piece of information that I wanted to put. Maybe I want to put their employee ID as the first item. Well, if I'm referring to everything by name and I change my data structure, I can still refer to everything by name. So there's a lot of reasons this name thing would work. You'll also notice it looks a little bit like a row in a relational database. So when we get to the point where we're reading rows of relational databases, reading a row of relational database into a dictionary with the fields named is kind of very logical, very much parallels a relational database. So that's what's going on here. And I've made two customers. So customer one, the data type of customer one is dictionary. The dictionary has two items in it, and each item in the dictionary is of data type text. The first name is text, and the last name is text. I made a second customer, and here I did this carefully. I said the first name and the last name, the items in that list are the same. So I'm being consistent with my customer one and customer two. If they're independent variables, I didn't have to be consistent, but I'm going to use that to so that I know both of those I could access the first name. And then I print customer one is customer one. That prints out the, let me see, that prints out here, that prints out the entire dictionary, right? So when I print customer one, it prints the whole dictionary. But then how do I access the data in the dictionary? Print customer one's last name, comma, customer one. Here we go. Square brackets, right? We're using square brackets. In this case, it's kind of like where your indexing would be if this were a list. But instead, we're putting the word last name and it says which item in this do we want. And here the order doesn't matter. You know, we can say right now we want the last name, we could want the first name or whatever. So then it looks up last name in the dictionary and gives that, prints it out, last name, Lovelace. Okay, so up to line 13, I have created two dictionaries. One dictionary is called customer one and customer two, and I made them similar formats to each other, which kind of looks a little bit like a database, you know, like a table, kind of, if you think of it that way, because it has field names. We don't call them field names in a dictionary, but it looks like that. And now here's where I'm doing a line 14 or starting line 15. I'm making a compound collection data type, right? Customer one is already a dictionary and it already has two pieces of information in it. Now in line 15, I create a list of dictionaries. My customers equals, it's a square bracket. Square bracket's a list. So we know my customers is a list and it has two things in it. So it's a list with two things in it. But the data type of customer one is in fact a dictionary, and the data type of customer two is also a dictionary. So it's a list that has two dictionaries in it rather than two just plain variables like we saw earlier. This is something where the main difficulty is just, you know, if you're doing this on a large scale, really, you might do it piece by piece. Remember which square brackets line up with which square brackets, which quote lines up with quote. You'll kind of want to build these things piecemeal so that you make sure you're building them right. Now, so my customers, see, I use the plural here instead of customer. I use my customers. So my customers is a list of customers. That list is two customers long. What happens if I get a new customer? So line 16, I get a new customer. New customer is of data type dictionary and has a first name and a last name. So that's my new customer. But then look what I do in line 17. Line 17, my customers dot append. Remember, my customers is a list. Append puts a new customer on it. And after line 17, I have a list of three customers. Now, line 18. Line 18, how would I print out my customer's first name using the variable my customers, which is a list, right? Here's where we access data in this thing. Line 18, read this over. My customers, that's the list. So a list can be indexed. So my customers square bracket 0 is the first item in that list. What's the first item? The first item in my list is actually a dictionary. So that's customer one. And a dictionary is accessed by using square brackets and the word of the field I want. So you'll see there's sort of two levels of indexing because my customers is a list of dictionaries. Therefore, I first say what item in the list I want. And then right after it, I'm saying which item in the dictionary I want. Okay. So that's how you And again, this could be any level, right? There could be 10 levels of these. So you're really looking at this closely, making sure you have things in the right order. There's a quote here that means the field name. There's a quote here that's the end of the F string, and the F string start up here. So a lot of things are going to be put together in one line of code. You don't necessarily write these lines of code like from beginning to end. Write part of it, see if it works, and then add a piece to it, right? Okay. Now, here's the cool thing about all of these objects with multiple things in them. They work with our for loop. Remember, we used our for loop to do something with each character in a string. This is kind of like that. Look at what happens in line 19. For customer, new variable name, in my customers. So if my customers is anything iterable, we say iterable, but it's really anything with multiple pieces in it. That means we're going to assign those pieces one at a time to the variable customer, execute the block of code, and then reset customer to the next one. So for customer and customers, customer is initially set to way back there, my customer one that I made, and I'm going to print out that's just an index of what number I'm up to so far, and the customer's first name. So line 24 prints out what you see down here, 012 Ada Grace Feifei, right? So one at a time, the first name customer is assigned to customer. The data type of a customer is still a dictionary. So my customers is a list of dictionaries. The one customer is a dictionary, and that's why this print statement uses customers if it's a dictionary. But when I loop through this, the value of customer changes each time it gets incremented to the next one. So the for loop works really nice to do something to every item in an iterable object. And you'll see that over and over. And there's lots of ways to do it. All right. And again, these last three lines, 28, 29, and 30, you can see first I print out my customers. That's this. What is my customers? My customers is a list of dictionaries. And that's this whole line of code here, right? All this stuff. It's a list of dictionaries. But then I print my customers index one. That's a single dictionary. And then I print out my customers index one, last name. That's a string that is their last name, Hopper. So yeah, a little bit complicated, and it really ramps up as you could layer this into. You can have a list of dictionaries, and an item in the dictionary is a list, and it could be a list of integers or whatever. So this shows two levels. We could have more levels. We will when we start talking about transferring data to services across the internet that may provide us with a bunch of information, and we'll have to kind of know how to pick through all that. The lesson learned from you just have to be very systematic when you're writing it. And also when you're reading it, kind of like put your hands over part of it, right? Read in, okay, the whole thing is a list. So it's a list of things. Now, one item in that list of things happens to be a dictionary. So you'll have to walk yourself very carefully through those levels to understand that. So I hope that was good. Thanks, and we'll see you next time.